Hello and welcome to another video, this time on question 11 from Pure Core 2, which was on November 2020 paper. Now, I'm sure a few of you will ask about this question, so I thought I'd do a little video of it. Okay, so how we do this? Well, firstly we've got to find the coordinates of P for this modulus equation here. Now, my first thoughts are, this is just like when you've got completed square form. If you had 2 times x plus 4 squared minus 5, the reason why you can immediately identify the minimum vertex at minus 4 minus 5 is because this bit is definitely 0 or bigger. Yeah, and so if you're trying to minimize y, find the lowest point of y, then that means you're going as low as possible on the graph, and so that will happen, the y will be minimized when this is 0, and that happens when x is minus 4 and it gives you a y coordinate of minus 5. Well, exactly the same argument can be applied to mod of x plus 4 because it's greater than or equal to 0, and so if you want to find the minimum value of y, this must be 0, in which case x is minus 4 and the y coordinate would be minus 5, and that's the coordinates of P. Another way you can look at it as well, and this is a really important skill because it helps you with all sorts of things like finding the range on loads of graphs and stuff like that. But if you actually think about how we build up the graph, you know, you'd start with one you instantly recognize, and I would suggest just learning that is a V shape at 0 with a gradient of 1, a gradient of minus 1. It's y equals x there, y equals minus x there. Well, if we build that up, this is just a transformation 4 to the left. So it's now going through minus 4 and 4. This just stretches it in the in the y direction by a scale factor of 2. Apologies, I haven't properly labelled it because I'm just doing some very quick sketches to try and build up how I get to this graph. Now all that does is double the y coordinates. It doesn't change minus 4 there, but it changes this 4 up here into an 8, because now when x is 0, y is 8. Okay, and then lastly, we just moved it down 5. And that's why it's at minus 4, minus 5 there. That also tells me, by the way, that must be now at 3. And so there we go. That's the whole graph. I've got a good picture of it now. So that's minus 4, minus 5. Next, we had to solve this equation. Now, this is a little bit subtle because when you get a straight line, if a straight line has gradient less than this one, if you see what I mean, like half or whatever, but it is still above the minimum point P, above there, yeah, then it's going to have 2 solutions. But it's easily possible for a modulus graph to hit a straight line once. If you had, for example, a very steep negative gradient going down like that, it would hit it once. And if you had, as we do in the next bit, a steep gradient here. This is steeper in gradient than this one, isn't it? So it's going to be coming down like that, and it's going to be hitting at 40. Now the difficult bit here is knowing whether it's going to hit to the right of P or to the left of P. You might be certainly confused about that. That's my initial thoughts here when I'm doing this question, because this is up at 40 and I can't really do this to scale. But this is really very steep, and it might be hitting there, or it might be hitting over. Is it possible to fit it over here? Yeah, it is, because it's possible to be of steeper gradient and hit over here. Yeah. So the big question is, how can I decide which line is right here? Because this is what I'm actually doing. Because for this part, this side of the line is just where the x plus 4 is positive, so you get 2x plus 8 minus 5. So that's like the equation of line y equals 2x plus 3, at least as far as P. Yeah, be careful, at least as far as P. Whereas this one is like the negative of the x plus 4, so it's 2 times minus x minus 4, and then minus 5. And that obviously gives you y equals minus 2x minus 13. Yeah. Now you could try now, because it's pretty easy now, to just let this one equal 3x plus 40 and this one equal 3x plus 40. But you must determine then which answer is actually correct and which answer is what you might call a phantom solution. That's what I'm going to do here anyway. That's my approach to this question. You could, of course, add 5 to that side, divide it by 2. Yeah, should we do it in another way? I've just seen another way, a more obvious way. How about we add the 5 and divide it by 2, and that equals mod of x plus 4. And so what you can say then is, okay, either x plus 4 positive equals 3x plus 45 over 2, yeah, in which case you're going to get 2x plus 8 equals 3x plus 45, in which case you're going to get x equals minus, okay, what is that, minus 37, I think, because 45 take away 8 is 37, yeah, so we get x is minus 37 there, yeah. Now I don't think actually that will work in this, yeah. Let's give it a try, yeah. Let's see. If I plug in minus 37 here, I'm going to get on this side minus 37 times 3, that's minus 90 plus minus 21, minus 101, plus 40, yeah, leaving on you like, what is that? That's going to be 61, negative 61 on that side. So we've got negative 61 on the left hand side. Then when I plug it in here, I get minus 37 plus 4, which is minus 33. But then I make it positive to give me 33, times it by 266, take away 5, I get positive 61 on this side. You get a little ghost solution. Oh, that's interesting. I'm going to call it a ghost solution. It's a phantom. Yeah. Why did it happen? Well, it's because if you look at the graph, you can see why it's happened. It's only going to hit one of these lines, and it's actually the other one which it hits. So you've got to make this negative minus x minus 4 equals 3x plus 45 over 2. I think they've done this on purpose. So you get minus 2x minus 8 is 3x plus 45. And so we're going to get now minus 5x on this side and minus 53 on this side. And so by the look of it, x is like 10.6. Now, have I got the signs all right there? Positive 53 on that side, 10.6. I was thinking my answer doesn't make sense because it was definitely happening on the negative side somewhere. But it's going to be at minus 10 minus 10.6. Let's get that right. I might want to check that answer afterwards to make sure I've got it right. Now, in terms of like what the graph looks like, what that shows us, this minus 37, I guess that was with... Yeah, well, it was on the positive side, wasn't it? It was when I assumed x plus 4 was positive. So that's this one going down there. I get a ghost solution down there. It must have been the more closer x-coordinate, if you think about it, out of the two that I was going to get. It's not happened down here. And also, but both are to the left of minus 4, yeah? And to the left of minus 4, the one it hits is this one, not that one, yeah? So this must be a phantom solution, if you see what I mean. But it's hard to see that. The easy way to check for phantom solutions is plug it back in at the end, yeah? And see if it actually works in the equation. But that's a subtle question, that is. So watch out for that. Another way you can get it is, yeah, you might be able to square both sides as well. That's kind of risky, though. That introduced ghost solutions as well. So yeah, watch out for what I'm going to call it there. The technical word for them is extraneous solutions. Look it up. But yeah, extraneous solutions. It happens all the time, really. If you get a negative answer, but you can only accept positive, that's considered an extraneous solution. Anyway, okay, what we got next? The line y equals ax intersects this at least once. So this is this business of how often something intersects something. Now, I suppose, actually, can I get out GeoGebra for this? Yeah, I'm going to get out GeoGebra. 1 second. Oh, no, that's something else. GeoGebra. Where is it? Yeah, I think I'm going to draw a little graph of the situation here because it's really handy for seeing this. I mean, I can try and draw it by hand. In the exam, this is what you'd have to do. We've got... No, it's going to be much nicer, actually, if I can draw it. I'm going to draw it for you on GeoGebra. Y equals 2 abs of x plus 4 minus 5. Okay, I'm also going to put a graph. Just give me one moment here. Fast forward the video at this point if you like. And let's have this going from like minus 10 up to 10. Okay, right. And then y equals kx. Okay, I think I can do this now. Let me just take a... I think this will be visible in the window. I'm pretty sure it will do. Okay, I hope so, otherwise I'm going to have to do the whole video again. Okay, so what have we got here? We want to make sure that this line, this is y equals ax, and I'm just moving it around as a varies, yeah? It's the gradient of a. The gradient of a is changing that line. But we want it to hit only once. Now, can you see it's hitting only once up to there? It's hitting only once, hitting only once, hitting only once. Now it's not hitting at all, now it's not hitting at all, now it's not hitting at all. Oh, it's hitting twice now. It's hitting twice, yeah? And right the way up there, it's always going to hit twice until it doesn't hit it at all, yeah? So let's go back to the question. what do they want from us? They want a range of possible values of a so that this straight line hits this modulus function at least once. Yeah. Okay, so just drawing it out now, like but you want to have that kind of vision of what was happening in your head. Basically, we want our line to either be really steep, then it will be hitting it at least once, or over here, then it'll be hitting it at least once. Over here was fine, at least once, at least once. I'm just trying to vary the gradient. Once the gradient gets beyond there, though, and gets really steep, then it only hits it once. Now, we want it to hit, what is it? Oh, at least once. Yeah. So that's good, yeah? Okay, let's bring the diagram back in because it's much clearer on this, not on my, silly diagram. Okay, so we want at least once. Now, can we note that, like, okay, there's very few times when it doesn't hit it, basically. If if A is a steeper gradient than 2, yeah, then it's going to intersect that line somewhere because that line's got a gradient of 2. But if it's less than 2, oh, but it must be greater than, oh, let's get to it. When it basically right up to that point there, it's not hitting it at all. Those are the only values when it doesn't hit it. Otherwise, it's always hitting it. Do you see what I mean? So really, the critical values we care about are the gradient 2 and the gradient of that line which passes through minus 4, 5. Yeah, and that's really all I need to consider for this question. So when is the gradient 2 or minus 5? Well, a equals 2, yeah, will give no solutions just because it's parallel to the line. And actually, when we want the gradient to be hitting the point minus 4, 5, which is a minimum point, well, what's the gradient of that line? Well, let's just do the old gradient trick. 5 over 4 is 1.25. And that's why if a is less than or equal to 1.25, or if a is strictly greater than 2, then you will get at least one touch, at least one intersection. Okay, I hope that video made sense. I hope it was useful. It's really tough, that last bit, though. Don't worry about if you don't get that in the exam. It's like, it's not the end of the world because a lot of people won't. Okay, I hope you enjoyed the video, and yeah, keep up the hard work. Bye-bye.